Good. So in this section, we're going to be taking a look at the derivatives of the trig functions, section 2.4. So we know how to differentiate the sine of x and the cosine of x. So in today's video, we want to differentiate the tangent of x, and then we want to also take a look at the derivatives of the reciprocals here. That would be cosine of x and secant of x and cotangent of x. Good. So let's start off with the tangent function. The way to differentiate the tangent is to rewrite that as the sine of x over the cosine of x. And so now we'll use the quotient rule on the sine over cosine to get y prime. So we take the derivative of the top, which is the cosine, times the bottom, which is cosine, minus the top function, sine of x, times the derivative of the bottom. Remember, that's a minus sine of x, all divided by the bottom function squared, cosine squared. Good. Now on the top, you might notice that we have cosine squared plus sine squared, and then all divided by cosine squared. And this will simplify quite a bit, because this is the what our book is calling the fundamental identity. I'm calling it the Pythagorean identity, and that is that sine squared of theta plus cosine squared theta equals 1. Good. So you can replace the numerator by a 1, and then we have over cosine squared x. Now normally we're not going to be calling this 1 over cosine squared. Normally we're going to be calling it the secant squared. Okay, so if you're thinking about putting together a table of formulas, right? So far, what we have is the sine, derivative is cosine, and then cosine, derivative is minus the sine, and then tangent is now secant squared. Good. So we'll continue now with the others. How would you get the derivative of cosecant? Derivative of cosecant would be the derivative of 1 over the sine. So we could write y equals the cosecant, which is 1 over the sine. Okay. Yeah, there were different ways of doing this. We could just use the product rule again, since we've used it once before. So the derivative of the top function is 0, so that makes that easy, times the bottom, minus the top times the derivative of the bottom, divided by the bottom function squared. Good. And so this becomes minus cosine over sine. We can rewrite that as minus cosine over the sine times 1 over the sine. There's a reason why we would want to do that. So this is actually minus cotangent of x times cosecant of x. Good. I will leave to you to, well, we can try one more. Let's try, how about secant? If y equals the secant of x, well, how would we compute the derivative? Well, the derivative, let's go ahead and rewrite it first before we compute the derivative. Y prime is equal to 1 over, I did it again. Y is equal to 1 over cosine of x. And now we can take y prime. Top function, derivative of the top is 0. Bottom function is cosine of x minus 1 times the derivative of the bottom, which would be minus the sine of x, all divided by cosine squared. Good. And so that gives us sine over cosine squared. Okay. And so this can be rewritten just like we did the last one as sine of x over cosine of x times 1 over cosine of x. And this is how you typically would see it. This is the tangent of x times the secant of x. Okay, and so therefore, when you're building your table of derivatives here, this is the derivative of the secant is sometimes people call it secant times tangent, or tangent times secant, however you want to write it. Very good. And so while we're at it, we just have that last one, which is the cotangent. Right, so we might as well go ahead and do that one. So we do that by rewriting the cotangent first. So that's going to be cosine of x over the sine of x. Sometimes I put in parentheses, sometimes I don't. I hope that's not confusing. So then y prime is equal to derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by bottom function squared. And so again, if you look up on the top, you see minus sine squared minus cosine squared. And so that would simplify to just minus 1, right? And that's by the fundamental identity that our book's calling, which is the Pythagorean identity, which is what I call it. So minus 1 over the sine squared. What is that? That is minus cosecant squared. Good, so cotangent is minus cosecant squared. Good. So one last thing before we go here, and let's just take a look at our table of derivatives all together now. So this is really what we were building, right? So let's just go ahead and write them down here. F prime. Good, so we have sine, cosine, tangent, and then we have our cosecant, our secant, and our cotangent. Okay, so the derivative of sine is cosine. Derivative of cosine is minus the sine. Derivative of tangent was secant squared. Good. Now, derivative of secant was secant of x tangent of x. And so derivative of cosecant ends up being minus the cosecant cotangent of x. So notice the relationship here, right? The derivative of a cofunction is negative, and this one will also be negative, and that'll be minus cosecant squared. And then notice how these pair up. Derivative of secant, or derivative of tangent and cotangent are very similar, and the cosecant and secant are very similar, right? Good. And then, so the derivative of the cofunctions have a negative sign in front, right? So we have a negative sign here, negative sign here, negative sign here. Good. So those are the derivatives of the trig functions.